back to the multiplication area. So if you happen to have access to a set of these physical toys, feel free to, lay them out on your desk and take a picture of that as part of your assignment instead of drawing it or using the app. If
that is a good idea. I never thought of that.
Yeah. So Amy, does your school district have base 10 blocks?
Yep, we have all kinds of fun math things.
Yeah, cool. Yeah, so if you can get access to a school district that has these, go for it. And if anybody's ever in Pendleton and wants to stop by Emigrant Hall and borrow some of these from me, I'd be glad to loan them out. I usually do that when we meet in the classroom anyway. All right, so back to, let's see, share my screen. So the goal here, now I just want to keep something in mind. Your goal is to clearly communicate these problems to me. Now to do that up front, you've got to make a statement. So for example, here in my picture, I'm saying if multiplication is an area, base times height, then what is 2.3 times 1.2? So you got to have some setup for the problem. And then here I drew my picture, I labeled it, and then I show both the expanded algorithm and the standard one. Now these are a pain to type, but I know a lot of you like making computers do what you want. So feel free to do both of them, but I expect to see at least one of them. But it's good practice to try them both. If this expanded algorithm up here freaks you out and you don't like it, don't do it. I'm not going to make you do this one right here, but it is something you will see in some textbooks and worksheets that kids will use in the elementary grade. So you will see this again in the future if you teach in a grade that has decimals. In my my description here, I showed 1, 2, 3, 4 pictures. And from you, really, I just need this last picture. I was just kind of going through my mental layout. How do I build these? And first I draw my area, right? And then I think about wholes and fractions. Then I think about my base 10 blocks. And then I think about how the answer comes out of this. So if you're attacking these problems by immediately doing the algorithm and then playing with the toys, that's backwards of what I want you to do. What I want you to do is build the area either by drawing it with base 10 blocks in mind, using the app for base 10 blocks, or using the real base 10 blocks. And then from that area, pull the answer out of that. So that's the way I want you to try and approach these, not by using the algorithm first. The point of this is to where does the algorithm come from? And the algorithm came from realizing that multiplication in reality is an area often, and that area can then point out the answer. All right, questions on this multiplication activity about what I'm hoping to get from y'all? Okay, so my inclination today, if I was in this class, I would do the drawn one, the hand-drawn one, because I'm sick of being on my computer. I'm on my computer way too much doing stuff, so this is way more appealing to me today. So mine would be I would submit 4 pictures like this right here for my assignment, or 4 of them. But if you're not having problems with your computer and you love playing with this stuff, then use the Number Pieces app, or maybe you have some other way to draw this on a computer. I'm always interested to see new technology. All right, so let's move on to the multiplication algorithm and why it works the way it does. And I kind of already alluded to that in a previous example. There we go. And the multiplication algorithm for decimals comes from the multiplication algorithm for fractions. And so some examples that build up to the algorithm that I showed a minute ago, if I take a 10th times a 10th, right, that's literally, when we speak it, 1/10 times 1/10. And we know that we should multiply our numerators and we should multiply our denominators. And why do we multiply our numerators and denominators? That just comes from, again, multiplication is an area. And so I think I got this about right. So if I take 1/10 this way by 1/10 this way, then I'm only concerned about this little block out of this whole region, which is a 10 by 10 region. So that one spot right there is 1 out of 100 pieces. Okay. So motivation of why this works the way it does comes from the interpretation that multiplication is area. And we need to know what a whole is. So my whole is this big square, 1 by 1. I have 1/10 of it by 1/10 of it, which is 1 out of 100 pieces. And so when we take tenths times tenths, we end up with hundredths. And the observation that we make here is that there was 1 decimal fraction place here and 1 decimal fraction place there, and that led to 2 decimal fraction places in the answer. And it turns out it doesn't really matter whether we have whole numbers mixed in here. So if I had something like 1.2 times 2.3, for example, that is a couple ways I can look at that. That's 1 2/10, or I could say it's 12/10. This is 2 3/10, or I could say it is 23/10. Right? Both interpretations work there. And then as far as the fraction answer, we know it's going to be 12 times 23 over 10 times 10. As far as 12 times 23 goes, and the kids are masters, oops, wrong place, of multiplying with this standard algorithm for whole numbers. 2 times 3 is 6, 3 times 1 is 3. Then we move on to our tens place. 2 times 2 is 4, 2 times 1 is 2, and then I get 6, 7, 276. Now that's just my numerator here, right? 276. It's hundredths, which means I have to shift the decimal point. And so the algorithm comes from that. However many decimals you start with, decimal fraction places, you have to end up with that many too. Just really it stems from multiplication of fractions, and multiplication is area, is where the algorithm comes from. So if I put my decimal points back in there, they have to go like that. And so that's the algorithm. And I'm just being careful to say that they're fractional decimal places, because this 2 is in a decimal position. It's the ones place, right? Decimal just means based on 10. So the number of fractional decimal places in the product, right? The product is the answer, is the total number of fractional decimal places from each factor. And remember, one definition of factor is something you multiply by. So I'm multiplying by 1.2, so that is a factor in this multiplication equation. So that means 1 2/10 times 2 3/10 has to equal 2 76/100. Why? Well, because multiplication is an area. That's where that comes from. We just happen to have this algorithm that works. Who cares about why? It works, right? So an algorithm doesn't care about why, it just tell me how to do it. I don't care why I'm doing it, just tell me how to do it. Right? Modeling is what we're doing with those toys. That explains why the answer is what it is. Why the heck should the answer be 2 76/100? That's why, right there. I can draw that area and see 2 76/100. If But I don't want to have to draw that area all the time, right? I just want to make the computation. Or I want to tell the computer to do it for me. How does the computer know how to do it? Because somebody programmed these rules into the calculator to make it happen. So that's it, the multiplication algorithm. Identify the number of places in each factor. That's how many decimal places there have to be in the answer. And then otherwise make believe they're whole numbers. Ignore the decimal points except for that rule. And we're done. Next topic, division.